Here's an audio narration based on the provided information suitable for text-to-speech, focusing on the technical aspects of adjustment factors for conductors with load diversity. We're addressing questions related to Annex B Table B.310.11, titled Adjustment Factors for More Than 3 Current Carrying Conductors in a Raceway or Cable with Load Diversity, specifically concerning the 70% adjustment factor for 10 to 24 conductors. These factors include the effects of a load diversity of 50%. 1. Let's define load diversity. Load diversity refers to the variation in electrical load demand placed on a system over time. It represents the difference between the total connected load, which is the sum of all the loads connected to the electrical system, and the actual peak load, which is the maximum demand experienced by the system at any given time. This difference occurs because not all connected loads operate simultaneously at their maximum rated capacity. Load diversity is typically expressed as a percentage and is determined by the characteristics of the loads connected to the system, how they are used, and the operational patterns of the facility or area being served. A load diversity of 50% indicates that the peak load observed is only 50% of the total connected load. This implies that at the time of peak demand, on average, only half of the connected loads are operating at their maximum capacity, or a combination of loads resulting in 50% of their combined maximum load. Understanding load diversity is critical for accurate conductor sizing, overcurrent protection, and overall system design, as it prevents oversizing electrical infrastructure, resulting in cost savings and improved efficiency. 2. Clarification regarding conductor size and insulation type. The adjustment factors provided in Annex B Table B.310.11 are generally applicable to situations where multiple current carrying conductors of the same insulation type are installed in a raceway or cable. The examples provided in the calculation examples demonstrate the use of the adjustment factors for conductors of the same size and insulation type. While the table does not explicitly address the use of conductors of different sizes or insulation types, it's crucial to understand the underlying principles. The adjustment factors are designed to account for the increased ambient temperature within the raceway or cable due to the heat generated by multiple conductors carrying current. The heat generated is directly related to the current flowing through each conductor and its resistance. When conductors of different sizes are used, each conductor will have a different ampacity and a different contribution to the overall heat generated within the raceway or cable. In such scenarios, a more detailed analysis is often required to accurately determine the appropriate ampacity adjustments. This might involve calculating the individual heat contributions of each conductor and considering the thermal resistance of the insulation and the raceway or cable material. To ensure proper application of the adjustment factors when dealing with conductors of different sizes or insulation types, it is recommended to consult the relevant electrical codes and standards such as the National Electrical Code, and specifically Section 310.13. It is also a good idea to seek guidance from a qualified electrical professional. They can perform the necessary calculations and assessments to ensure that the conductors are sized correctly and that the installation meets all applicable safety requirements. Note that Table 310.15b2 mentions a 50% adjustment for 10 to 20 conductors without mentioning load diversity.